Okay, so today we're going to do a real world kind of problem. You know how salesmen get paid sometimes based on how much they sell? Paid on commission, it's called. And so for today, Nemo has agreed to be my example guy. And you don't know it yet, but you're going to grow up to be a dental salesman. So I have a relative who actually does this. He sells teeth. Isn't that a weird idea? Because, like, say you're a hockey player, a professional hockey player, and you get your front teeth knocked out. Happens. Or even if you're just a pretty girl who is biking and falls and smashes your front teeth on the sidewalk. Can you imagine how awful it would be to have to go around for the rest of your life without front teeth? Well, they can put in fake ones that look exactly like the real thing. Yeah, exactly. A couple grand for your tooth. And that's just for the tooth. That doesn't even count the installers, so you know. Okay. So if you are a salesman who sells these teeth, they can do jobs where you only make commission. Like the company doesn't even pay you except they give you like a percentage of whatever you sell. All right. So let's say in this case that when Nemo sells these teeth, he makes more money for front teeth than back teeth. Let's say that he makes 50 bucks for selling a single front tooth. You know, it seems weird, but honestly, that's the kind of thing. And these numbers will work out to be about right for how much a person would make, a professional level person. So if you're making 50 bucks commission for selling a front tooth, you get how that might be like 10% of the cost of the tooth of $500, something like that. Okay. So anyway, if he makes 50 bucks for the front tooth, do you get right away? I got to keep track of all this stuff. There's so much. I've already told you so much stuff. So let's pick X is going to be front teeth. And you'll notice every one of your problems does this. We have to decide what to make what. And Y is going to be, well, let's just say back teeth. Do you get why it probably doesn't matter as much what the teeth in the back look like? Because the teeth in the front are the glory ones that everybody gets to see when you smile and stuff. Okay, so we're going to make X front teeth and Y back teeth. Do you get if I put this dot right here, that could represent how much he sold one day? He went to a dentist and he sold him, well, what would that mean? What would that spot right there of 3, 1, what does it mean? He sold 3 what's? Front teeth and 1 back tooth, okay? All right, so when we're done with this graph, it's going to look kind of like this, and then it's going to be all like shaded in. What are the important parts of this thing that we're shading? Where they intersect, yes. So like spots like this where the 2 lines intersect, spots like that. Why wouldn't that spot be important in this case? Because you don't shade down there, because we shaded above this line right here, and so that's not part of the, what's it called again? Feasible region. The feasible region are the places where everything overlaps. All right, so I don't want to do the whole problem here for you. I want you to do the problem. But we need to write some more equations, because so far all we know is he makes 50 bucks for the front teeth. And this is part of his little profit equation. I'm going to stick with profit. Yeah, you could probably argue it's revenue, because he actually has to spend some money to drive to the dentist's office and stuff. But we'll just say P equals, maybe actually a lot of companies reimburse you for your mileage. So maybe he's going to get that part paid for because they reimburse his mileage on the job. The companies usually reimburse you about 55 cents per mile. So if you drive for 100 miles, they'll give you 50 bucks. Why? Because you got to pay for the car. The cars aren't free and gas isn't free and you got to buy insurance and all that stuff. So P is equal to 50x. What do you have to know now? But Y is, which is what? Number of chickens in Bolivia? The back teeth is Y, but what do we need to know about the back teeth? Not how many. How much? There's a difference. How many is Y. How much he makes for selling back teeth, we're going to say since they're less glory, he's going to get less money. 20 bucks is his profit, his salesman's profit, his commission. Okay, so you know what? C, P in this case probably isn't the best. I'm going to actually change it to C. Everybody, you got an eraser on your iPad. Change it to C. That'll stand for commission. His commission will be 50 for each X plus 20 for each Y. I want you to now label that. Just a shortcut for it, but op eq. What do you think that stands for? Do you remember from the optimization equation? Good. That's the optimization equation. You don't graph that. You take the points from your graph. Let's say we get a, like the overlap right here, and it's shaded up like this, and that's a corner of it. You take points like that and you stick it into your optimization equation. You don't graph your optimization equation. All right. So now here's some more stuff. Let's say that they expect, this is normal. It's obviously, on a bad day, you go to the dentist, he doesn't want to buy any, okay? So you just stuck selling them nothing. But they do say they do averages, and they say a typical day you sell at least 2 front teeth and 1 back tooth. I just gave you 2 equations. You write them. Typical day you sell at least 2 front teeth and 1 back tooth. You only go see the sales, the salespeople only see the dentist like once every couple of months, because it's not like people are losing teeth like crazy all over the place. But when he goes out to sell, sits down with the dentist, and he says, yeah, I could use 6 front teeth and 2 back teeth. Okay, so in this case, I just gave you 2 equations, x and y. Could there be more equations than that? Yeah, you can have tons of equations. But to start with, Mr. W, give me what you thought these equations were.
X is greater than or equal to 2.
Notice he said greater than or equal to 2. Because we didn't say he's only going to sell 2. That would be equals 2. Might be 2 or more. Okay? Y is?
I forgot what number.
That's all right. What did I say? Class? 1? Okay.
At least 1.
So at least 1. So how would I do that?
Greater than or equal to 1.
All right, good. Why do you think more front teeth are sold than back teeth?
More people knock out front teeth.
Yep. And if you lose a back tooth, you actually can just live without it. Nobody even knows, and just, now if you lose a tooth in the middle of a bunch of other teeth, it can cause problems because then the teeth start moving around, shifting a little bit. Yep. But if you lose a back tooth, you can actually just let it go. In fact, a lot of people have their back teeth pulled. You know what they're called? Wisdom teeth. Very good. Anybody actually had them pulled yet? You already had them pulled? Wow. Cool. Interesting. Not very wise, apparently. Hmm? Yes? Oh, interesting. Had all 4 of them. Yeah, you'll have fun that day. Of course, you'll be asleep. You'll never even know what happened. Yes, and then you'll have cotton in your mouth. Be like, what's happening? I'm dying. Okay.
They never put her to sleep,
Oh, yep. They're actually putting you to sleep? Yeah.
My mom was in a lot of pain.
Yeah.
For like the next couple of weeks.
Yeah. It can be pretty traumatic if they don't put you out. Yes?
My cousin had her wisdom teeth pulled, and like when she woke up, she had like this mouth stitch because they like ripped. Wow.
Ah, they tore her mouth? You too?
Mine were growing sideways into my other teeth.
Oh. Oh. Okay. All right. Anyway, we're going back to, let's say, again, this is typical. You're going to sell at least, typically, at least 5 teeth. How do I write that as an equation? Notice I said teeth. I didn't say front. I didn't say back. Try to think for a second. Don't just copy the kid next to you. Think for a second. I'll pause for a second while you think that through. At least 5 teeth. Okay, you should have said, instead of just picking x or y, you say x plus y needs to be more than or equal to, did I say at least? All right, 5. Okay, now, that's the first equation you couldn't actually put into a calculator. What would you do? Get y alone. So you subtract x from both sides, and you get y is greater than or equal to 5 minus x. That's kind of a dumb way to write it. Yeah, you actually put it in the calculator that way, but how should you write it? Negative x plus 5. Good. Because that way you've got the slope intercept form, and you know, oh, y-intercept is 5. So again, we can go up to 5, put a dot there. And then how am I supposed to graph this? Yes, you can plug in things for x, or you can just look at the slope and go, I know the slope is rise over run, and it rises -1. What does that mean? It goes down 1, and then what's this? Runs 1 or over 1. Down 1 over 1 puts you right there, and if you just keep that pattern going, it's like that. Okay, now, how do I graph x is greater than or equal to 2? Oh, wait a minute, I haven't finished this line. Is it a solid line or a dotted line? Solid. And it's because I said or equal to. And then which way should I shade? It says greater than. What do I shade? Yep. Above it is another way to say it. If it's greater than, you shade above it or to the right of it. Okay. Now we need the two more other equations in there. And this one's going to form a shape that you've never seen before. The feasible regions are going to look different. X is greater than or equal to 2. Here's x is equal to 2. How do I make it greater than 2? Shade to the right. Okay, and last but not least, you got the red one here, which is going to be greater than or equal to 1. Here's equal to 1. How do I do greater than 1? Above it. Most common mistake is to go, oh, I see a triangle. There's my feasible region. No. Why not? Which line screws that up? Which colored line would not be true then? The blue line isn't working for that. Okay, so instead, the feasible regions where all three overlap. Would you please shade in what you think the feasible region is on this? And then compare it with the kid next to you and see if yours looks right. I'll pause for a minute. I want you to do this, do a good job on this. And if you're lost, ask them for help. Okay, did you shade in? I'm going to go just around the edges of it. Like that. And did you notice it goes forever? It doesn't stop just because your graph stopped. It goes forever, and I want you to think about why. Why would it go forever? Because they can buy lots and lots of teeth, right? You hope that they want to buy like 1,000. Now, every now and then, if you're a salesperson, you're going to run into like, ooh, I got this one dentist, and he's like really popular dentist. He's got like 6 chairs, and he's got 4 dentists working for him, and I was able to sell way more to him. I have a relative who actually does this. All right, so that means there's no limit. So how in the heck do you get the maximum? Well, you don't. They wouldn't ask you for the maximum then. What they'd ask you for is what is the minimum profit that Nemo's going to make on a typical day. Well, what are the important spots? The corners. So would you agree that this right here is a corner? All right, and this right here is another corner. Do you get why I could go forever that way? I'm not going to pick any of those points because I could go forever that way. And the more he sells, the more he makes. And so the minimum has got to be one of these two. Where am I going to stick the 4, 1? That's this point right here. Where am I going to stick that? In the optimization equation. In this case, it's the C equals, which was, do you remember what C stood for again? Commission. 4, 1, or it could be 2, 3. One of those is more than the other, and that's not the question. We want to find the one that's less than the other one. So 4, 1 versus 2, 3. Those are your two choices. Which one gives him less profit? Why would he want less? He doesn't want less, but at least he'll be able to say, I know at least when I work for this company, I'm going to make, and again, this is barring on your bad days, on a normal day, I'm going to make at least whatever. Well, you stick in the 4, 1 by doing this. 50 times 4 plus 20 times 1. And what does that give you? 220. So either 220 or that other combo, 2, 3, 50 times 2 plus 20 times 3. That's this one here. That one gives us how much money? 160. Moral of the story, what's the least he's going to make on a typical day? 160 bucks. And that would be a way to try to sell him on taking this job. Like if you go sell a dentist on a typical day, you're going to make at least 160 bucks. And some days you're going to make like 700 bucks from that one sale. I know a guy who worked on commission and he made 10% commission. And yeah, it's a good healthy commission. There are jobs like that where you get 10%, but they don't pay you anything else. So like you either sell or you get nothing. And he sold a $1 million account. So what did he make? 100,000 bucks. So that's some good cash. Let me give you another example of that. Realtors. You know what a typical commission is for a realtor? Anywhere between 4 and 7%. The highest around is like 7, maybe actually it's like 7.6 or something, but I'm going to go with 7. So let's say you make 7%. Do you agree there's a few $1 million houses around you? You sell a $1 million house and you make 7%. Can anybody do it in their head quick? 70 grand, $70,000. That's like how much a teacher makes, more than a teacher makes in the whole year. You sell that one house. So there's good money to be made in those commission jobs. Now, also, in bad times, nobody's buying houses. And then you just sit there and don't make anything. So commission can be really good in good times and really bad in bad times. So they get based on that percentage. But usually, if you're a realtor, you work for a big realty company, and they take part of it. Nope. Usually, they don't pay you. They just pay you commission. Most realtors, it's just commission. Now, unless you work for a realtor like you're his assistant or something, that's different. Then they pays you hourly, but you don't get anything for commission. But most realtors are on commission. They sell a house, they make good money. They go for a while without selling houses, they're making nothing. So it's feast or famine. All right. So anyway, in this case, what's the final answer? 160. And that was the minimum amount he could expect to make. So minimums are where you're looking for the lowest amount. Of course, in other problems, they're going to ask you for the maximums. In this case, there is no maximum, so they couldn't ask you for a maximum. All right, let's just jump right into the homework. It's going to be just like this. So everybody, look for day 3 in Schoology. I'll pause while I find it. All right, so hint, on this lesson 3, linear work programming worksheet C, this very first problem is a pain in the butt. And from my experience, I don't think it's worth it. It's good to be stretched, but this one gets everybody all confused, and I don't think that's worth it. So we're skipping the one called Mrs. Wilson's Vitamins. Okay? Instead, we're going to Magician's Payment. You guys have seen where speakers come into school, and those speakers don't come here just to be nice. They get paid. And in your case, I doubt they get paid anything based on any commission. But when people come to perform, usually they get a percentage of the cut. Like, you know, when a band comes and performs at the Xcel Energy Center, they get a percentage of how much the ticket sales are. Okay, so when the Def Leppard comes, if there's been $1 million in ticket sales, their deal might be we get 80% of the cut. Okay, and that means they get 800,000, and then the Xcel Energy Center gets the other 20% or whatever. Okay, or maybe it's their manager. I'm sure this is complicated, but you get paid based on how many people come. Well, this Magician's Payment, what they're trying to do is, again, do a minimum. Notice it says, what is the minimum amount of money he could receive? Because do you get, when they invite him to come and perform, they don't know how many tickets they're going to sell. So that's why they want to tell this guy, at minimum, you're going to make what? And then if the guy knows, well, at minimum, they've guaranteed me I'm going to make $2 grand. Okay, and then maybe if they sell more, I'll make $3 or $4 grand. So it's going to be a lot like the one we just did with the teeth. Okay, so let's read through it quick. Your school is contracted with a professional magician to perform at the school. The school is guaranteed an attendance of at least 1,000. That doesn't mean they're going to force 1,000 people to sit there. It means that if 1,000 people don't buy tickets, they will pay for enough to like make up for that. And total receipts of 4,800. Let's make sure you get the difference here. What is this? Number of tickets. What is this? Total money brought in for ticket sales. You get they're both based on tickets, but this is actual number of tickets, and this is actually how much they made from those tickets. Those are two different things. We need equations for those eventually, but we're not ready yet. The tickets are $4 for students and $6 for non-students, basically adults, of which the magician receives $2.50 and $4.50. Whew, numbers all over the place. Hint, magicians, the money he's going to make, this is your optimization numbers. That's like profit. So think of it from the magician's point of view. His profit, or I'll use, somebody in class keeps referring to this, his revenue, because yes, he will have to buy rabbits to pull out of his hat and things like that as their expenses, but his revenue will equal $2.50 for each, well, how do I know which one's X and which one's Y? It says right here. X is the student tickets, Y is the non-student. So let's make that profit function together. In this case, it's a revenue function. R equals 250, what? For each X. So we say 250 times X plus 450Y. Do you remember me saying you don't graph this? You don't graph the optimization function. Okay. We got to write some more equations, some X equations, some Y equations. You can tell me an X equation or a Y equation or a combo of the two equation. Yes, sir. Ooh, that's a combo equation. X plus Y. Total tickets has to be what? You got it. Very nice. Why? Because of this sentence right here. The guaranteed an attendance of at least 1,000. That means total tickets is going to be the X plus Y. It has to be greater than or equal to 1,000. How many think you could have written that equation? You get that. Okay, good. Then, this is definitely harder. 4,800. Well, something adds up to 4,800. Somebody can do it in here. What do you think?
Is that the R equals, is that the same thing?
Nope, it's not the same thing. This is the revenue that the magician makes. That's different. He's taking that from the ticket sales. The ticket sales are 4 and 6.
So would it be 4 X plus Y X plus 6X?
There you go. You worked it out. And now, just be careful of this last part. This is the total amount they make is...
Greater.
There you go. Very nice. That's it.
I got those.
You got it. You were given a hard answer. Why the 4 and the 6? Because $4 is the cost for the tickets that are X tickets. Those are the cost of the student tickets. That's from this right here. $4 for students and $6 for non-students. That's where that 4 and 6 came from. Okay, so now, if I can only put these in the calculator and do it, well, you can. So grab your graphing calculator. You can copy what you see on your calculator screen when you're done, and that can be your graph. You don't have to do this on graph paper this time. So now, you can't just put them in the exact way they are. Calculators want them solved for what? Y. All right, so if I'm going to solve this for Y, what's the first thing I do to the blue equation? Yep. And then this becomes Y is greater than or equal to negative X plus 1,000. Pop that in your calculator. Now you might be saying, wait, how am I supposed to do greater than or equal to? You can't yet, but just put in Y equals negative X plus 1,000. Or you could do 1,000 minus X. It's just a little more professional to put it in slope intercept form and say negative X plus 1,000. That's my second equation on my graph here, negative X plus 1,000. Now, do you see what on my graphing calculator I tweaked? That's not normal. Don't say color, because some calculators do color and some don't. That's not it. What's different about my Y2 equation than would as anything I've ever graphed before in here? It's so hard to see. You're staring right at it, but you don't see it. Yes. A black triangle. Did you even notice that right there? You have that too. If you're too far away to see that, I apologize. Okay, so look on your calculator to the left of the Y1. Do you see that there's a little line there? But you can change it by hitting enter. You can change it. All you'd have to do is hit enter a bunch of times, and eventually you'll have the triangle. And obviously there's a triangle up and there's a triangle down. That means shade up or shade down. So if I do triangle up for that one, because it's greater than, and again, all you have to do is hit enter a bunch of times, and it'll change from this to that to this to that. You want the up triangle for shade above. I'm going to pause for a second while we help people with individual issues. If you got a color calculator, you can change the colors too. Don't rub it in for those that don't have the color calculator. Okay, now I solved the other one already, the red one, and I got negative 2/3. You might have 4/6, but it reduces to negative 2/3 x plus 800. Just want to clarify how that happened. I'm just solving this for y. So you subtract 4x from both sides. And then once you're done with that, you divide by 6. And then you'll have negative 4/6 x plus 4,800 divided by 6, which turns out to 800. That's how I got that solved for y. And then here's my two equations. And you want above on both of them because they both say greater than or equal to. Now when you're done, if you hit graph, you probably won't see anything because you have to get your window to be really big. You want to be able to see out to 800, remember? Or 1,000 even. So always go bigger than necessary. And so maybe you should make your window go to x is 1,000 and y is 1,000. Maybe even more. I'm going to go to my window. Remember, on this kind of thing, it's go big or go home. Because if you don't go big enough, you're going to have to do it again. So I'm going to make it like 1,500 on x and 1,500 on y. And you hit graph. Now with colors, it's especially nice because you get the two colors overlapping, and they'll actually make them shade in opposite ways, like one shades vertical bars and one shades horizontal bars. All right, if you take honors pre-calc next year, we're going to show you a really cool kind of graph. It's called polar, and you can do all kinds of, that makes this look like nothing. It's really cool. Okay, anyway, this one, would you agree that's a spot where two lines cross? You can find that with second calculate intersect now. You won't have to do any complicated algebra to solve it. Second button, calculate intersect. It's number 5. Second calculate intersect. And now you get close to where they intersect, and then you just go, okay, enter, enter, enter. As long as you only graph 2 lines, it's simple. It jumps right to the answer. Now remember, is this 600 light bulbs and 400 antelope? Think about it. It's 600 what's? What are X's again? Students. 600 student tickets and 400 adult tickets. Now, that's one of the numbers you can put into your optimization equation. Mr. Magician doesn't get $600 and $400. He gets 600X and 400Y. So you put a 600 here and a 400 here. This guy's going to actually make some serious coin. 250 times 600 plus 4.50 times 400. That would be one of the possible amounts he could make. You have to compare that with this spot and this spot. Why? Because they're the corners of the feasible region. Some people think this spot is, but no, it's that right there is not part of the feasible region because there's no blue by it. See what I mean? So it's only the 3 places I circled. Now the one that's easiest is the calculator going second calculate intersect. Everybody can do that, and I have it on the screen here. X is 600, Y is 400. Now these it takes up a lot of paper and you have to stay organized. So if I were making a little list of my points, I would go, okay, so I got 3 points and put them in a little chart here. And I'd say one of the points was at 600, 400, and it gets me how much money? And I don't know, has somebody actually typed this in yet? 2,300? 3,300? Okay. $3,300. So is that for sure the minimum? No. We have to look at the other two. Maybe he'll make less under this scenario. Think about it for a second. That's a whole bunch of X and no Y. That's a whole bunch of students and no adults. Look at his profit function. Does he make more on students or adults? Adults. Okay, so if you're looking for the minimum, this is probably going to be a lot more money because he's going to sell a whole bunch of adult tickets, a whole bunch of Y. So if you want the minimum, it's one of these two. I just don't know for sure which one it is. Because this has got a whole lot of Y and he makes a lot of money on the Ys. He makes $450, almost double for adults. All right, so this one came out to 3,300. This one, that's the trickiest thing. It's the blue equation and what? The y-axis, the x-axis. The x-axis is where what? Yes, y equals 0. So if it's the blue equation and the x-axis, it's actually the blue equation and y equals 0. So if I have the blue equation right here, moving this over, here's my blue equation, and y equals 0. Actually, I think it's blue on my calculator, but it's red on the screen. My bad. It's this one. It's this equation. It's that equation, except it's also the x-axis, which is where y equals 0. Do you get I can put a 0 right here then? And then you solve it. And you'll have 6 times 0 is 0, is greater than or equal to 4,800 minus 4x, or I could have said negative 4x plus 4,800. How do you solve that? Well, you're a algebra student. In fact, you're a higher algebra student. You should be able to do this. Just solve for x. What's your first step? Subtract 4,800 and then do what? Divide by negative 4, exactly. Then you'll have your answer. That's going to be a number of x's, which is antelope, right? What that, write our x's again. Tickets for what? Student tickets. So when you're done, you'll know how many student tickets this spot right here is. So then you'll know that that's, I don't know, how many student tickets was that? Somebody solve it yet? 1,200. Thank you. 1,200 comma 0. Why? Because at that weird spot on the graph, there was no adult tickets and 1,200 student tickets. And then you got to figure out how much money that is. Please don't say it. I want people to have to do some of this themselves. I just did almost completely your first homework problem for you. I wanted to show you how that would work. Okay? Your assignment then is to just do the next one. We're not going to go back up and do that vitamin one. It's a nightmare. Instead, let's have you do this next problem here called Rachel's Vehicles. You'll be able to do one from start to finish with a calculator. Remember, the important spots on the graph are where the lines cross. If something like that and you end up with something like this, then these spots are your possible answers, the corners of the feasible region. And those spots you stick into the optimizing function. The optimizing function is usually profit or cost. In this case, you're optimizing the number of miles. No, you want to optimize as how far she travels because she wants to travel as far as possible. So, all right. I'll leave it to you. You only have one problem to work through. Start by making equations, graph your equations, find that ideal area, the feasible region, take the corners of it. Those will be your answer. One of those corners has got to be your answer. All right. Remember, you don't have to be perfect yet. The test isn't until when? Tuesday is correct. Yes. I'll help you with those. I have to stop the video here, and that's all I got for the video for today.